Somewhere in an ancient cloud of gas and dust, a journey begins that will eventually light up the night sky. But how does a star actually come to life? And what decides its spectacular end? The story of a star might seem like cosmic myth, but it's as real and dramatic as any epic ever written. Imagine drifting through an immense, cold nebula, just a swirl of hydrogen and dust, silent and dark. For millions of years, nothing about this cloud changes. But then, gravity starts doing its slow, invisible work. Particles tug at each other, clumping just slightly. Over time, those clumps grow, gathering more mass. A point comes when the cloud's own gravity is so strong that it begins to collapse in on itself, heating up as it shrinks. Deep at the core, pressure and temperature begin to rise until the heart of the cloud ignites in a nuclear inferno. This is the birth of a star. The intensity is staggering. Temperatures soar to millions of degrees. Hydrogen atoms fuse together. As each one unites, they release energy. This is the forge that powers galaxies, the process that allowed every star you've ever seen to shine. Let's pause here and consider one of the oldest poetic lines about beginnings. In the Rigveda, an ancient Indian hymn, the creation of the universe is imagined as a golden egg, luminous and silent, hidden inside darkness. Then was not non-existent nor existent. There was no realm of air, no sky beyond it. What covered it, and where? And what gave shelter? Rigveda 10:129. That questioning wonder still echoes in modern astrophysics. We know much more than ancient poets, but as we look into the birthing clouds of stars, we're still awed by the mystery of how something comes from nothing. Once nuclear fusion starts, a star enters what astronomers call the main sequence. This is, in some ways, the stellar equivalent of adulthood, a long, stable phase where the energy from fusion perfectly balances the force of gravity trying to crush the star. Stars at this stage live for millions or even billions of years, serenely fusing hydrogen into helium. The bigger the star, the more furiously it burns through its fuel, and the shorter its life will be. In the poem Stars by Sara Teasdale, she writes, "Alone in the night on a dark hill, with pines around me, spicy and still, and a heaven full of stars over my head, white and topaz and misty red. Myriads with beating hearts of fire that eons cannot vex or tire. This idea that stars are eternal, immune to change, is an illusion. They do get tired. Their fuel isn't infinite." At the end of main sequence, the story shifts. Reflection. Teasdale's poem captures a sense of permanence, but in reality, every star is living on borrowed time. The same shining fire that enchanted the poet also carries the seeds of the star's own destruction. When we stare up, we're always seeing something both ancient and impermanent. As hydrogen runs low, the star grows unstable. The balance between gravity and heat breaks down. The core shrinks and heats up, and the star's outer layers swell dramatically. The star becomes a red giant, or, if it started off even more massive, a red supergiant. In Dante's Divine Comedy, the stars guide the way. The love that moves the sun and the other stars, the poet writes, famously using starlight as a symbol for cosmic order and hope. But up close, the love that moves a star is fusing atoms and staggering pressure, not celestial harmony. Red giants are truly alien. Our own sun, billions of years from now, will bloat until it swallows Mercury and Venus. Its outer layers will glow faintly scarlet, growing cooler even as the core turns into a seething ball of helium and heavier elements. The giant phase isn't peaceful. it's wildly dynamic. Over time, these giants shed their outer layers, puffing away vast shells of gas into space. The exposed hot core in the center shines brilliantly, illuminating the colorful gas clouds around it. This gas becomes a planetary nebula. The word planetary comes from early astronomers who thought these bubbles looked a little like distant, blurry planets through their telescopes. In reality, it's not a planet at all, but the last, beautiful breath of a once stable star. Let's recall the closing lines from Tennyson's Ulysses. And though we are not now that strength which in old days moved earth and heaven, that which we are, one equal temper of heroic hearts, made weak by time and fate, but strong in will to strive, to seek, to find, and not to yield. The star, fading, still struggles onward. Even as it weakens, it transforms its corner of the cosmos, pushing into the unknown. The fate of the core depends on the mass it started with. Lower mass stars, like our sun, end as white dwarfs. This is a stellar ember, about the size of Earth, but many times denser. It cools over billions of years, growing ever dimmer, until it fades to black, a cold relic in a silent universe. But for the universe's most massive stars, the ending is anything but quiet. The red supergiant's core collapses catastrophically. Protons and electrons are crushed together, creating a tiny, hyperdense core. In just a split second, the outer layers rush inward, strike the core, and rebound outward in a titanic blast. This is the supernova, a single event so bright it can outshine an entire galaxy. Poetry can hardly do justice to the violence of a supernova, but John Donne came close in his holy sonnets. Like as the waves make towards the pebbled shore, so do our minutes hasten to their end, each changing place with that which goes before. In sequent toil, all forwards do contend. Stars, like lives, surge forward, only to meet an end, and in doing so, they begin something new. The shockwave from a supernova spreads heavy elements, iron, gold, uranium, through space. Without supernovae, there would be no planets, no people, no poetry. Every atom in your body heavier than hydrogen was forged in the death throes of a massive star. Who imagined that our most destructive forces would also be creative? The philosopher Heraclitus reflected that the road up and the road down are one and the same. The end of a star's life is also the beginning of something else. The ingredients for planets, life, and future stars. When you look at your own hand and know it is stardust, you're recognizing a cosmic cycle that's billions of years old. And then, from the shattered remnants, another journey may begin. Sometimes a supernova's collapse is so extreme that no force in the universe can stop it. Gravity crushes matter into an infinitely small point. A black hole is born. Or, if the core resists total collapse, it becomes a neutron star, a city-sized object with the mass of the sun, spinning rapidly and beaming energy like a lighthouse through the dark. Each stage is strange and spectacular, both an ending and a beginning. The full life of a star stretches through phases that aren't just steps, they're transformations, reshaping everything around them. In the words of Rainer Maria Rilke, "Let everything happen to you. Beauty and terror. Just keep going. No feeling is final." The narrative arc of a star's life teaches us something essential. The universe is never static. Becoming and ending are two sides of the same cosmic process. No star dies without giving something back. The atoms forged in supernova explosions, the nebulae glowing from a white dwarf's fading core. These are the foundation stones for everything we know. So the next time you gaze at the stars, let curiosity guide your wonder. Each point of light is a story in progress, a life begun in obscurity, kindled by fusion, growing and aging, and finally scattering its gifts across the heavens. The universe writes its history not in years, but in cycles of birth, transformation, and renewal. When we reflect on our own fleeting lives, we find kinship with the stars, both subject to forces vast beyond our comprehension, both transformed by the passage of time, and both, in some way, destined for endings that become new beginnings. The life cycle of a star is the universe's way of renewing itself, an endless story told in fire and light. And as we peer deeper into the cosmos, we're reminded that we're part of that story too, carried forward on particles born in the heart of a sun billions of years ago. So what will spark the next beginning? And how many universes are yet to be born from the remnants of stars still shining far out of view? The sky above is full not only of things that are, but also things that have been, and things that someday will be. In the heart of each star, silent and unseeing, the drama of creation and destruction plays out, reminding us how much wonder there is left to discover